From knowledge bases, to ontologies. This is episode 1, the knowledge problem. Now, ontology can sound like an intimidating word, something out of a philosophy seminar. So before we touch a single definition, I want you to actually feel the problem that ontologies exist to solve. Because once you feel it, the rest of this series becomes obvious. So let us begin with a question that sounds far too easy to be interesting, and then watch it quietly fall apart. Imagine you run a university, and you ask your computer system one simple thing. Which of our professors can supervise a new PhD student in knowledge graphs? To you and me, that is almost trivial. But watch what the machine has to do. The answer is scattered across at least 4 different places. The professors are in the HR database. Their research areas are buried in PDF profiles. The rule, that only a full professor with an active grant may supervise, lives in a faculty handbook. And whether anyone has an open slot is in someone's head, or a spreadsheet nobody keeps up to date. Now notice something genuinely important here. Nobody in this story is missing any information at all. The university already holds every single fact it needs, written down somewhere. And yet the machine still cannot answer, because nowhere does it actually know what a professor is, what the word supervise means, or how any of these things connect to one another. The data is entirely present. The understanding is entirely absent. That gap, between merely having the data, and actually understanding it, is the exact problem this whole series sets out to close. So let us back all the way up and ask the most basic question of all. What, really, is a knowledge base? In the broadest possible sense, it is simply any place where we keep what an organization knows. That is it, nothing more exotic than that. But here is the catch. Historically, that knowledge has lived in 3 very different forms, and every one of those 3 forms carries its own fatal weakness, a weakness that quietly stops a machine from ever using it well. First, documents. Reports, manuals, emails, slides. They are rich in meaning, but that meaning is written for humans, not machines. Second, databases. Neat rows and columns, easy for a machine to read, but they store values, not meaning. A column called status holding the number 2 tells the computer nothing about what 2 stands for. And third, the most powerful and most fragile store of all, human experts, whose hard-won knowledge walks out of the door the day they retire. 3 forms, 1 shared problem. None of them lets a machine reason about the knowledge itself. It helps to lay these 3 forms on a single line, a spectrum of structure. On the far left, unstructured knowledge. Free text, images, conversation. Maximum richness, and almost zero machine readability. In the middle, semi-structured. Spreadsheets and tagged documents, organized, but only loosely. And on the far right, structured knowledge. Formal, explicit, and typed, the kind a machine can genuinely compute over. Here is the pattern worth remembering. Almost all of an organization's knowledge begins life over on the left, in messy human form. And the entire job of knowledge engineering is to carry it rightward, toward structure, without spilling the meaning that made it valuable in the first place. Now you might reasonably object. We already have databases, and we have had them for decades. Is a well-designed database not already structured knowledge? Not quite, and this is the crucial distinction at the heart of this whole episode. A database stores data. It does not store meaning. Here is a tiny example table. Person 7 reports to Person 3, and Person 3 reports to Person 1. The database records all of this faithfully, and it can even follow that chain upward on request. But ask it a slightly different kind of question. Is Person 7 a manager? Could a person ever manage themselves? And it simply falls silent. It does not know that managing someone makes you an employee too. It does not know that the chain must never loop back on itself. It does not even know that these IDs stand for people at all. To the database, they are simply numbers sitting in cells. A human being reading the very same table fills in every bit of that meaning automatically, without thinking, purely from context. The machine cannot, because that meaning was never written down anywhere it could read. The structure captured the what. It quietly threw away the what it means. And that one missing layer, the meaning, is exactly what this entire series will teach you how to write down. Scale a single table up to a whole organization, and this one gap explodes into 4 very concrete panes. Fragmentation, the same knowledge scattered across docs, databases, and people, with nothing tying it together. Heterogeneity, where marketing's customer and finance's customer are quietly not the same people. Lost knowledge, when an expert leaves and takes their understanding with them. And the modern one, knowledge that AI simply cannot use safely, trapped in silos, under rules that demand auditable decisions, while the new language model confidently makes things up. 4 different pains, but one shared root cause. And here is where it gets interesting in 2026, because surely large language models have already fixed this. And they are extraordinary. They have read more text than any human ever could, and they answer in fluent, confident prose. But the moment you care about knowledge, a language model has 3 deep problems. Its knowledge is implicit, locked inside billions of weights you cannot inspect or point to. It is unverifiable, with no reasoning chain to audit, and every so often it hallucinates, stating something false just as smoothly as something true. And it is hard to update, where getting one new fact in can mean retraining the whole model. For a casual chat with an assistant, all of that is perfectly fine. Nobody gets hurt. But for a hospital deciding on a treatment, a bank approving a loan, or a factory running a process, fluent but possibly wrong, with no way to tell which, is simply not acceptable. What every one of those settings actually needs is knowledge with 3 properties. It must be explicit, so you can point straight at it. It must be verifiable, so you can audit it and prove it. And it must be updatable, so you can fix it the very moment the world changes. 3 properties. And they are exactly the 3 that a raw language model lacks. So let us pull it all together. Scattered knowledge, structure without meaning, and AI that cannot be trusted to truly know. What is missing, through all of it, is one single thing. A shared, formal, machine-readable map of a domain's meaning. The concepts that exist, like professor and student. Their properties, like a name or an active grant. The relations between them, like supervises and teaches. And the rules they must always obey, like every PhD supervisor must be a full professor. Capture those 4, formally, and a machine can finally reason the way you and I did at the very start. That map has a name. It is called an ontology. Over the next 7 episodes, we build this idea up from the ground. We will define an ontology properly and meet its 5 building blocks. We will trace 40 years of history, from Greek philosophy all the way to modern AI infrastructure. We will separate ontologies from their close cousins, knowledge graphs, rule systems, and large language models, and meet the one simple equation that ties the whole picture together. A knowledge graph is just an ontology, plus data. Then we go properly technical, the formal stack, querying, building, and reasoning, and we finish in the world of neuro-symbolic AI and intelligent agents. And so the journey is the title itself. From knowledge bases, to ontologies. By the time we reach the end, you will not merely know what an ontology is in the abstract. You will know how to build one with your own hands, how to query it, how to reason over it, and how to wire it into a modern AI system so that it actually behaves. That is the destination. Next time, Episode 2. What is an ontology, really? See you there.